Hello everybody, Mr. Vidich here. Today's lesson is on prime factors, lesson 1.1. Before we jump into it, we're going to do a bit of a review on divisibility rules. So we'll go through those right now. How do we know if a number is divisible by 2? Well, that's pretty straightforward. If the last digit is even, i.e. 0, 2, 4, 6, 8, if a number ends with any of those numbers, it is going to be divisible by 2. Okay, number 3, how do we know if a number is divisible by 3? Well, we're going to add up all the digits in that number, and if that sum of those numbers is divisible by 3, then the number itself will be divisible by 3. Okay, number 4. To check if a number is divisible by 4, we're going to just look at the last two digits of that number. And if that number is divisible by 4, then the whole number will also be divisible by 4. Number 5 is fairly straightforward. If a number ends with a 5 or a 0, then the number will be divisible by 5. Number 6 is a combination of rule 2 and 3, and both the divisibility rules for 2 and 3 have to work if a number is going to be divisible by 6. So you just have to check if it's divisible by 2 and 3, and it will be divisible by 6. Number 7 is a little bit trickier. We're going to take the last digit of the number, double it, and then subtract it from the rest of the number. And if that answer is divisible by 7, then the number will also be divisible by 7. So let's do a quick example. Okay, let me just zoom in here a little bit so we have some room to work with. Let's do number 2. Let me get my pen here. 238. So let's check if that is divisible by 7. Put a little equal question mark here. Okay, so what is our rule? Well, we take the last digit, which is an 8. We double it to get 16. And then we're going to subtract or take away 16 from 23, and 23 minus 16 is 7, and 7 divided by 7 works. We get a whole number, therefore 238 also works. So that's good. And the answer to that would be 34. Oops, let me get my pen here. 34. We'll do another example after. Okay, let me zoom back out here. Oops, gotta select the... Sorry guys, just getting used to this program here. There we go. Alright. Okay, let's look at 8. If the last 3 digits form a number that is divisible by 8, then that number will also be divisible by 8. So it's very similar to rule for number 4, except we're not looking at the last 2 digits, we're now looking at the last 3 digits. The only thing with this rule is that most of us do not have memorized whether 3-digit numbers are divisible by 8. But let me do an example here just to see if it works. Okay, I'm just going to zoom back in here. We'll go next to 8 over here. And let's do a number 1352. And we're going to check if it's divisible by 8. So our rule says we're going to take the last 3 digits, 352, and check if that number is divisible by 8. Well, 352 352 divided by 8 gives us 44, and therefore 1352 should also be divisible by 8. So it's not the most helpful rule because, like I said, none of us probably know that 352 is divisible by 8, but it's a lot easier to calculate to get an answer like 44 than having to do some large number of maybe 6 or 7 digits. So there's the rule for number 8. Alright, let's check the last one. And that is, or not last one, we have 2 more. 10 is fairly straightforward. If a number ends with 0, it's divisible by 10. So let's look at 9. So if a number is divisible by 9, the sum of the digits is also divisible by 9. So it's very similar to rule for digit 3. Okay, let's look at some examples. Alright, example number 1. Determine if 254,870 is divisible by 2, 3, and it wants us to check all the numbers up until 10. So let's start from number 2. So what was our rule again? If the last digit is even, it will be divisible by 2. Well, 2. So 2 works. Alright, let me check 3. Well, 3, we have to add up all the digits. Let's see, we get 2 plus 5 is 7, plus 4 is 11, plus 8 is 19, plus 7 is 26. Well, 26 is not divisible by 3, so our number is not going to work for 3. Okay, let's move on to 4. For 4, we check the last 2 digits, and the last 2 digits in this case are 70, and is 70 divisible by 4? Well, 70 is not divisible by 4, so our number will not be divisible by 4. 5 is fairly straightforward. If the last digit is a 5 or a 0, it will work. We have a 0 here, so 5 works. Alright, 6 automatically fails because both 2 and 3 have to work for 6 to work. So that's not going to work. So let's move on to 7. Well, the rule for 7 is, again, you have to take the last digit and double it and subtract it from the rest of the numbers. Unfortunately, this doesn't really help us here because we're still left with the large number. The last digit here is 0. If I double 0, I still have 0. And if I subtract that number from the rest of the digits, I get 25,487, and I have to do that on my calculator to check if it's divisible by 7. If you do that on your calculator, it indeed will be divisible by 7. So 7 works. Okay. Number 8. We're just going to look at the last 3 digits, and that's 870. Well, 870 is not divisible by 8, so 8 will not work. And if you're wondering how I got that, I look at 870. I know 800 is divisible by 8, but 70 is not. If it was 880, then it would work. Unfortunately, it does not work in this case. Alright, for number 9, we add up all the digits, and if that number is divisible by 9, then it will work. So let's look at the numbers again. What do we have? 7 plus 4 was 11, plus 8 was 19, plus 7 is 26. Well, 26 is not divisible by 9, so 9 does not work. Okay, moving on. Just going to zoom out here. Alright, let's get into today's lesson, and this will also be a review for most of you, but we're going to look at factors. Let's look at the definition of a factor. So a factor is essentially a divisor, and how we check it, if we get a whole number and we divide that whole number by another whole number, and if the answer is a whole number, then that divisor is a factor. So that was a bit wordy, but let's just do a few examples here. Hopefully it'll make sense. So example number 2, state the factors of the following whole numbers. And we're going to, let me make this a little bigger here. And we're going to look at the number 36. So the factors of 36 are all the whole numbers that divide evenly into 36. Well, 36 divided by 36 gives us 1. So 1 times 36 gives us 36. So 1 and 36 are factors. 2 times 18 are also factors. 2 times 18 also give us 36. 3 times 12 gives us 36. So 3 and 12 are factors. 4 times 9 works. 5 does not work. And then finally 6 times 6 gives us 36, but we're only going to take one of the 6's. So how many factors does 36 have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 36 has 9 factors. Let's look at 48 here. 48 is going to have even more factors. So again, the obvious one is 1 and 48. 1 times 48 gives us 48. 2 times 24. Does 3 work? Well, let me check. If I add up 4 plus 8, I get 12, and 12 is divisible by 3, so 3 should work. And if I divide 48 by 3, I get 16, so 3 times 16 gives us 48, so those are also factors. Alright, let's look at 4. 4 times 12 gives us 48. 5 is not going to work. 6 times 8 also gives us 46, and that is all for 48. So how many do we have here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 factors for 48. Let's look at example C. And again, 1 times 125 work. 2 does not work because 5 is an odd number, and 2 is not going to be divisible by 125 is not going to be divisible by 2. Let's look at 3. I'm going to add up all the digits. I get 1 plus 2 plus 5. I get 8. 8 is not divisible by 3, so it's not divisible by 3. Let's check 4. 4 also does not work. 5 does work. 5 times 25 gives us 125. 6 does not work because of the 2 and 3 rule. 7. As a matter of fact, those are the only factors of 125. So we have 4 factors for 125. Okay, moving on. Let's zoom out of here. Whoops, there we go. So that's kind of the first little section. Let's move on to the next. Okay, example number 3. It says, in each case, determine the number of factors of the given whole number. Well, we kind of did that in the previous example. So let's look at the first one, 7. Well, 7 is only divisible by 1 times 7. So it has two factors. 10 will be divisible by 1, also by 2, by 5, and then 10. So that would be 4. Okay, number 15. 15 is divisible by 1, by 1, by 3, 5, and 15. So that's a total of 4 factors. Moving on to example D, 18. Let me blow this up a little bit so I have more room to write with here. There we go. 18 has, let me move it over here a little bit just so it's easier to write. There we go. 18 has 1, 2, 3, 4 does not work, 5 does not work, 6, 9, and 18, which makes a total of 6 factors. Last example is 24, and 24 will have more factors. So the 1, 2 works, 3 works, 4 works, 6 works, 7 does not, 8 does, and 12 works, and then the last one is 24. Ran out of room there a little bit, which makes a total of 1, 2, 3, 4, 5, 6, 7, 8 factors. Okay, moving on to some definitions here. So how do we know if a number is prime or composite? Well, a prime number is a whole number that has exactly 2 factors, and those 2 factors will be 1 and that number itself. So in the above examples, only 7 is a prime number. So go ahead and highlight that or underline it in your notes. A composite number, on the other hand, is a whole number that has more than 2 factors. So all the other ones above here are composite numbers. Alright, let's see if I can list my first 10 prime numbers, and maybe you guys can do this on your own at home. It'll take me a while to get all 10 here, but let's go. Before I move on, this is an important rule here. The number 1 only has 1 factor and is neither a prime nor a composite, and 0 is defined as having no factors. So this is a trick. You can get a trick question here. They can ask you, is number 1 a prime number? Well, it is not. It is neither a prime nor composite. 0 is also defined as having no factors. So don't get confused on that one. So we start off our first number. Our first prime number is 2. Then 3. 4 is not, because 2 goes into 4. 5. 6 does not work. 7. 8, nope. 9 does not work. 10 does not work. 11 works. 13 works. And you know what? I'm going to ask you folks at home to list the first 15. So cross this 10 out here, and I want you guys to list the first 15 prime factors. So in our next class, we'll have a bigger list to work with. Okay, I'm going to move on to the following example number 5, we're going to classify the following whole numbers as prime or composite. Well, 46 is, I can easily tell it's a composite because it ends with a 6, and 6 is an even number, so 2 obviously goes into it. So I'm going to put a big C here. Oops, sorry about that. Big C for composite. 37 will be a prime number because no other number other than 1 in itself go into it. 39 is a composite. 101 is a prime, and 103 is a prime. Okay, so why is this useful? Well, we can use a technique called prime factorization. And go ahead and underline that there. We can write every composite number can be expressed as a product of prime numbers. This is called prime factorization of the number. The divisibility table or a factor tree can be used to determine the prime factorization of large numbers. So let's go through both of these methods here to determine the prime factorization of 48. So I'm going to show you guys both methods, but I prefer the factor tree method, and I don't particularly care which method you guys like, as long as you're comfortable with both and understand what they're all about. So let's look at a divisibility table and how that works. So we have the number 48, and we're going to put a little box like this around it, and we're going to just divide it by any number. We can choose any number, and the obvious one that jumps out at me is the number 2. And if that number is a prime number, I'm going to circle it. So what happens when I divide 48 by 2, I get 24, and then underneath that I'm going to make another box here, and I'm going to divide 24 by 2 again, and I'm going to circle it because 2 is a prime, and I get 12, and so on. I can do 2 again. I don't have to do a 2. I can do any other number that divides into 12. I can choose a number like 3, and I'll circle that as well because that is a prime number, and 12 divided by 3 gives us 4. And I'm going to run out of room here, so I'm going to write 4 is pretty straightforward. There's only one factor that's going to help us here, and that is 2. Circle that, and my last number I'm going to put underneath, sorry about this guys, I'm running out of space here, is 2, and I'm going to circle that number because it is a prime. So what did I just do? Well, the prime factorization of 48 we can write like this. So 48 equals 2 times 2 times 3 times 2 times 2. So I expressed the number 48 as prime factorization of those prime numbers. So let's look at the other method, that is the factor tree. So again, I'll start with the number 48, and this time I'm going to, sorry, I'm not sure what happened to these numbers over here. Let me just go over here a little bit and zoom in so I have more room. Okay, so let's look at the factor tree method. I'll just go up here. Alright, 48. So I'm going to do a couple branches here, and you don't have to do 2. You can do as your factor here. You can do maybe a 6, and 6 times 8 gives me 48. However, I can't circle it because neither of those are prime numbers, so I have to keep going down the factor tree. and 6 is 2, and 3 are factors of 6, and both of those are primes. So I'm going to circle them, but I'm still not done because I have this 8 over here, and 2 times 4 gives me 8. I can circle the 2 because the 2 is a prime, and I got to keep going. The 4 down here splits into 2 times 2, and both of those are prime, so I'm going to circle them. So you can see another method of getting the prime factorization of 48. So let's write it out as our answer here. I'm going to write it out. 48 equals 2 times 3 times 2 times 2 times 2. Okay, moving on. On to some bigger numbers, and example 7, and I believe this is our last example of the lesson. So, alright. Big number 2,772. Well, let's use the divisibility table here. And I'm going to, the obvious one again that jumps out at me is the number 2. So let's first of all write the number out here. So 2,772. Do my little half box, and I'm going to put a 2 here in red because it's a prime number, and then I gotta jump onto my calculator and divide 2,772 by 2, and I get 1,386. And I'm going to divide that by 2 again, and I get 693 as my answer. And that's not going to be divisible by 2, but let me check if it's divisible by 3. I'm just going to add up all these numbers, and I get 18, and 18 is divisible by 3, so that'll work for sure. So 693 divided by 3, I get 231. Alright, this might be a little bit trickier. 231. This might be a prime number. Let me just check a few numbers to see what divides into 231. Well, actually 3 will work again, because if I add up all those numbers, they add up to a number that's divisible by 3. 2 plus 3 plus 1 is 6. 6 is divisible by 3. And the answer actually I get is 77. And then 77, we'll give you a 7 and a 11. So the prime factorization would be 2 times 2 times 3 times 3 times 7 times 11 to give us 2,772. Alright, last one. 33,250, but using a factor tree. So I'm just going to jump in with my tree right from the start here, as opposed to rewriting the number, save myself some time. Well, I see a 0 here, and that means that it will have to be divisible by 10. And if I divide that number by 10, I get 33,325. The 10 is fairly easy. I'm going to put those in red, 2 and 5. And those are both primes. Moving on over here, I see a 5 here, so 5 will work, and 3,325 divided by 5 gives me 625. Oops, excuse me, 665. The 5 is a prime, so I'm going to circle it. And keep going down the line here, and divide that by 5 again to get 133. Circle the 5. Okay, 133. What's going to go into 133? 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 does not work, 7, maybe. Let's check 7. Well, if I remember my divisibility rule for 7, I take the last digit, which is a 3 here, I double it, so I get 3 times 2 is 6, and I take that number away from the rest of the number, which is 13. So I will get 13 minus 6 gives me 7, and 7 is divisible by 7, therefore 133 is divisible by 7, and as a matter of fact, it gives us 7 and 19, and both of those are actually prime numbers. So the prime factorization of 33,250 is 2 times 5 times 5 times 5 times 7 times 19 to give us, let me write it over here, to give us 33,250. Okay, that concludes our lesson for today. Thanks everybody for watching, and see you in class.